For the page 42 oral exercises, we're asked to simplify the expressions and then indicate the degree of the polynomial answer. Simplifying expressions means to combine like terms and then write the terms in order of decreasing exponent. For number 1, 7x and 3x are like terms. They both have the variable x. So we can add them by adding their coefficients. 7 plus 3 is 10x. For number 5, there's an s to the 5th power term and another s to the 5th power term. Those are like terms and they can be combined. So look at the coefficients. 2 of them, and then later subtract 3 of them. 2 subtract 3 is -1. And they were s to the 5th power terms that we were combining. Besides that, there's also a constant term, the +4. This is degree 5. I can see that I forgot to give the degree on number 1, so let's go back and do that one. The answer in number 1 is degree 1 because the variable has first power. Number 9, first step will be the distributive property, where you multiply the 2 to both terms in the parentheses. That creates 2 plus, now the distributive property, 2 times b is 2b, and 2 times +3 is +6. Now let's combine like terms. It's the constant of 2 and the constant of 6 which combine. So we have a 2b term and then +8. This is degree 1 because the exponent on the variable is to the first power. Number 15, some of the terms have x's and some of the terms have y's. Let's combine like terms. -7x and a +2x. -7 plus 2 is -5. And that had an x by it. Now the y terms, 2y and then later plus 9y. 2 plus 9. That's +11y. This is a degree 1 polynomial. Both variable terms go to the first power, so it's degree 1. For the written exercises, we're asked to simplify. We could perform the work inside the parentheses first, but that would involve adding fractions that don't have the same denominator. It might be faster to do the distributive property. 50 times the 1/5, and then 50 times the 1/2. 50 times a fifth, 1/5 of 50 is 10. 50 times a half, half of 50 is 25. Now we can add these together and see that the answer is 35. For number 7, we have 9x, and then we're adding this binomial. In the binomial, there is an x term that can be combined with the 9x term. Later, we're subtracting this binomial, and in the binomial, there is an x term. So let's focus on the x terms. Start at the beginning and just work from left to right. 9x add 5x. Is 14x. Then subtract 3x. That's 11x. Now the constant terms. We have a +2 and then subtract 8. That makes -6. Number 15. We have a 4-term polynomial and we're adding another 4-term polynomial. Let's look for like terms and combine them. The term with the highest degree is the x to the 3rd power term. Later on, there's another one of those. So let's combine. 5 of them plus 3 of them is 8x to the 3rd power. Now look at the x squared terms here and then over here. 7x squared plus 4x squared. So 7 plus 4, that's 11x squared. Now look at the x terms, here and here. -3x plus 5x. That makes +2x. And finally the constants. 1 minus 18. 1 minus 18 is -17. Number 17 is a very similar problem, but this time there's subtraction in the middle. The highest degree term is to the 3rd power. So let's find the b to the 3rd power terms and simplify. We have 1b to the third subtract negative 4b to the third. So 1 subtract negative 4. That's 5b to the third. Now the b squareds, here and here. Negative 2b squared subtract 1b squared. Negative 2 subtract 1. That's negative 3b squared. Okay, now the b terms, here and here. 3b subtract 2b. 3 subtract 2, that's a positive 1. So positive 1b. And now the constants. 4 subtract negative 1. 4 subtract negative 1 is positive 5. Number 19, similar idea. There is a term with x to the third power, but looking across the rest of the problem, there is no other x to the third power term to combine with that. So the final answer has 2x to the third power in it. This term here has x squared y squared as its variable part. Later on, there's another term that has x squared y squared. Those combine together. 7 of them plus 9 of them is 16 x squared y squared. This term is xy cubed. There is not another xy cubed term. So the answer has positive 10 xy cubed. Finally, this term here has nothing that combines with it, and so that transfers into the final answer, negative 3 x cubed y. For number 27, we're asked to solve for the variable that's on the left side of the equation. In this case, that's the variable d. Figure out the value of d when given values of a and t. Let's substitute. So d equals 1/2, and in place of the letter a, fill in 32, and in place of the letter t, fill in 3. Now it's a matter of performing these operations. 1/2 of 32 is 16, 3 squared makes 9, and 16 times 9, 144. For number 29, we're asked to solve for the variable c, and we're given a value of f. So let's make our substitutions. Rewrite the problem, but where the letter f is, fill in the value they give us, negative 4. Now let's simplify this to a final answer. Working inside the grouping symbols, negative 4 subtract 32 is negative 36. Now let's multiply this fraction to negative 36. How about a little bit of reducing? 9 divides into 36 4 times. So 5 times negative 4 is negative 20. Number 31, we're asked to solve for s. Let's make substitutions of the values they give us for the other variables. For g, 32. For t, 2. For v, 4. And for t, 2. And then simplify this expression. Negative 1/2 times 32 is negative 16. 2 to the second power is 4. Over here, 4 times 2 is 8. Negative 16 times 4 is negative 64. Finally, let's go negative 64, add 8. Because these have different signs, we find the difference of the numbers, which is 56, and choose the negative sign. Number 35 is a yes or no question. Given this equation, is the answer for x 8? To find out, let's substitute 8 where the letter x is and see if the left side ends up equal to the right side. So 8 plus 5 minus, and then 8 minus 20 over 8 minus 4. We're wondering, does that equal 16? 8 plus 5 is 13. Now let's focus our attention on this fraction. 8 subtract 20 is negative 12. In the denominator, 8 minus 4 is 4. Negative 12 divided by 4 is negative 3. So we have subtract and then negative 3. 13 subtract negative 3 does equal 16. The answer to number 35 is yes. Okay, number 37 is the answer for m negative 2. Let's substitute to find out. Put a negative 2 every place where there is an m. We're wondering, does that equal to this expression? Let's simplify both sides of the equation and see if we get the same result. Inside the grouping symbols, negative 2 plus 3 makes 1. So negative 2 times 1 is negative 2. Now over here on the right side, negative 2 raised to the third power is negative 8, because negative 2 times negative 2 is 4, and 4 times another negative 2 is negative 8. Then when you subtract 10, you get negative 18. We can see that these are not equal, and so the answer to this one is no.